So today we're going to solve the longest substring from a text. So I'm still focusing on substrings because I think this is a lot of problems that I've seen in the past, and a lot of people struggle with these types of problems. So when you're giving a large text, first the problem is saying that you should return the longest substring in the longest word in the text. So this is a text, for example. And then the longest word in this text is this word. And the longest substring in this word is this word. So giving a huge text, find the longest substring in the longest word. So that this is a two-part problem that tries to find your understanding in data structures of both mapping and slicing window. So let's see the Go template that I have set up. If you run this, so here's a huge text that I have. Longest word is empty substring, so we need to solve that. We need it to return something. So here's the main problem here. So we need to basically find the longest word here and then the longest substring within that longest word. And here's another example, and here's another example. All right, now that we understand the problem, let's begin solving this. So the first thing I always do is I get the length of the text. This is just a habit of mine. I'm using Go, by the way. And then even though if n is 0, return end, return response. Yep. So now the next thing I want to do is so this is a text that is separated by space. So in Go, we can, just like in JavaScript, you can split. In Go, you can split this by space into a slice of strings, an array of strings. So what I would say is I can say words equals, I'm going to use strings dot fields. So this now is an array of strings, as you can see. So now it's an array of my name is, so each one of that. So that's awesome. So now we can let's look for the longest word. Let's say the longest word, we don't know what that is, but we can say that the longest word, we can say for each, don't need the index, for each word in range of words, um, the length of word equals that. When we say if, well, this should be 0, longest word, 0. If length of word is greater than the longest word, then longest word equals length of word. That makes sense. So now we have the longest word. We have we have the length of the longest word. What am I talking about? So but now we need to get the longest word length. So I can say let's do longest word length. I'm bad at this naming thing. And then like this, and then this longest word, and then this would be that, that, and then now longest word would be the word itself. Perfect. So now we have the longest word. So we can return it, and we haven't created our response structure yet. So we can say response equals this, and then the longest, this is the response struct. So the longest word equals this. Perfect. So we need to get the longest substring now. Let's leave that empty for now. And then eventually we'll return res. So we have the longest word. That's good. So now we need to get the longest substring. So what we can say now is that we can say we from this longest word, from this longest word, we need to somehow track when we have seen each of the character. So I'll say last seen. I'm using a map. If you watch my other problems, you know this is an algorithm that we've done similar types of this. So the length of this would be the length of the longest word that we found. So the meaning the space, the length and the capacity for the map will not be longer than the longest word, which makes sense. So now I can say if let's see, we can say so. Let me see. I'm going to do this. So this is the longest word. So now let's assume BA is the substring. BA is a substring, but then when we see B again, this BATUND is the longest. So what we're going to do now is we're going to say that we need a way to track the start of the substring, the end, and the longest. So what I'm going to do is I'm going to say the start and the longest. So 0, 0, 0. Now this way, so now my goal is eventually, let's assume there's no BATU and let's say there's just BA. Then I need to know how to return BA. You know, so the start would be at B, the end would be at A, and the longest would be 2. You know, that kind of thing. So let's loop through each now. We can say let's do a for loop, a regular for loop, and then this would be here, and then the character of this will be the longest word here. So now we have each character. Somewhere we're gonna have to do last seen of CH equals the current index. I like the word current better than currents. Okay. So now we have this start. So let's see how this goes. For example, if we have BABATUND, so let's say this is the longest word. First, in the loop, we're gonna loop through B. We haven't seen B, so this CH here is gonna be B. So B is gonna be added to the map. Then next is A. We haven't seen A, so A is gonna be added to the map. So we're gonna have B 0, A 1. Then we get B again, but we have seen B. So we need a way to stop here and say, put the start pointer at the beginning of where we have seen B, and the end pointer at where we are at the second B. We need a way to do that. So we need a way to say if we have seen B. So in Go, we can do this. So last seen of CH. So I'm saying if OK is a Boolean, OK means so if it's there, if it's in the map, this would be true. So if true, enter this if condition. So meaning that, so B now, does the previous B exist? Yes, it exists. So enters here. So now I will say start equals the previous plus 1. Why am I adding 1? Because the previous is 0. So I want the start to start at 1, not B, not 0, so plus 1. And then we need to make sure that start never passes previous. So we say and previous is greater than start. So now we have this. The next thing we need to do is we need to check now. So B start as a result of seeing this second B, start is now 1. So let's assume there's no other characters and we want to stop here. So we need to return a BA. So we say end equals the current plus start plus 1. Why? Because current is 0, 1, 2, right? I mean current minus start. So 2 minus 1 is 1. 1 plus 1 is 2. So we need to return 2, BA, because we've seen the second B again. So hence BA is a substring. Now we can say if the if end is greater than the longest, then the longest equals end. So because there could be other substrings, uh there can be VAAB. So we need to account for stuff like that. Okay, so this is good. So next, what we want to do is, so now B, and as a result of this, would be 2. If 2 is greater than longest, so longest would be 2, perfect. And now, when we get to the other A, well, actually, no, first, we need to get the actual word. We need to know when it starts. So what I can do is I can say longest start, like when it starts. So when it starts, this would be the start, the longest start. Oh, start. So this is the start time for the actual longest. So we need to know the index of when the actual longest is. In my case, it's this second B here. So now what I'm gonna do is I'm gonna say, now that I know when the longest start, I can get the string out. So the longest string. So what I'll do, I mean the longest substring. So in my case, I can say the longest sub would be from the longest word, which is going to use the longest start. I'm going to slice it plus the longest. This would be the longest substring. And then I'm going to return rest. And that's it. So if I test this with my main function, let's see what I get back. Internalization is the longest word, and this is perfect. What I was expecting. Short longest test. Longest word here. Yep, that is the longest word. And then and just toward H is the longest. Because when it sees E, that's when the second one starts. You see the second E. So the start was from end.